Welcome back to Cypress Academy PSoC 6 101. In this video, I will show you how to add the I2C interface to our BLE Controlled Robotic Arm project. I'm going to use the bridge control panel as a dashboard to display the position of the motors. So as we change the position of the motors, you'll see a graph in the bridge control panel showing where they are. Does that sound cool? Yeah, I think so. Open the BLE Controlled Robotic Arm project schematic. Add the Easy I2C component from the catalog. Change its name to Easy I2C and leave the rest of the settings as their default. Assign the pins to P61 and P60 for SDA and SCL. Generate the application. Then we create and edit the Easy I2C task.h. This file will just have the pragma once and a definition of the Easy I2C task. Once that's done, we can edit the CM4 main application. When the whole main controller is done, there will be two ways to display updates to the position of the motors, specifically the Easy I2C and the BLE. In order for everyone to know that there's been a change to the PWMs, I'm going to use an event group. An event group is essentially an RTOS safe global uint32 variable. All of the tasks can read the status of an event group without fear of a race condition. They can also wait for a change in the event group. This is how we're going to communicate from the PWM task to the Easy I2C task. Let's get to editing. In main CM4, first include the Easy I2C task.h and the free RTOS events groups.h. Next, define the event group called PWM event group. And finally, in the main function, I'll initialize the PWM event group by calling x event group create and start the Easy I2C task. Before anyone can use the PWM event group, I need to add it to global.h. In this file, I'll add the include for the events groups.h, I'll add an extern for the PWM event group, and finally create a definition of the event group. Basically, a bit mask. The first bit will be for the I2C, and the second bit will be for the BLE. In PWM task.c, all I need to do is set all of the bits when the PWM has changed using the x event group set bits RTOS command. Now, let's create and edit the file Easy I2C task.c. This is a fairly straightforward file. First, include the project.h, the free RTOS.h, and the PWM task.h. Next, make the function Easy I2C task. I'll set up a variable to store the percent value of the motors so that the I2C master, the bridge control panel in this case, can use it to read and display the data. I'll call it motor percent. It's an array of two unsigned 8-bit integers representing the percentage of the two motors. I'll start the Easy I2C component, set up the buffer and mark it as read-only, and then start the infinite loop, and then initialize the motor percent array with the current value of each motor's PWM compare value. Then I'll wait for a change event in the group and then do it again. What happens is the task will go to sleep until the PWM task changes the event group. When that happens, the task will wait up, then update the values in the buffer, and then it'll wait for another change. That's it. Slick, isn't it? All right. Now build, program, and test this beast. Remember, if you still have the bridge control panel open and connected to the kit, you need to disconnect the kit from the software by clicking on the disconnect icon in the bridge control panel. Then go back to the PSoC creator and hit the program button again. Okay, now that we've got it programmed, go back to the bridge control panel and reconnect to the kit. Let's set up the chart so we can graph the motor percent values. Go to the chart menu, select variable settings. For the first row, click active and type M1 as the variable name. In the second row, Click Active and M2. OK. Next, in the editor, I'll type W80R8 at M1 at M2P. What this does is it sets the offset pointer to 0, then it reads in 2 bytes, which it then stores in M1 and M2. Now press enter a few times to see if it works. All right, that's good. Now just go to the Charts tab and hit repeat. You can change the values using your UART interface that we built before. Remember, press the keys OP and K and L in the terminal client. All right, now as we change those values, you can see the waveforms going up and down. Hey, that's what I call success. Now that we have an I2C dashboard interface for our robotic arm project, in the next video, I'll walk you through how to add a custom digital logic component to implement the Terminator kill, or the safety switch of the design that will safely stop the motors. You can post your comments and questions in our PSoC 6 community, or as always, you're welcome to email me at alan_hawse@cypress.com or tweet me at AskIoTExpert. Thank you.